long back, about an hour back. But I'm sorry due to some logical and other technological reasons we are delayed. But I'm happy that all the speakers for the technical session 1 are here, and I think I'm R.K. Trivedi, who is chairing this session, and with me Dr. Usmani, Professor Usmani is here, who is co-chairing this session. We have 6 speakers in this technical session. Definitely time allotted to the speakers is more, and it is very difficult for me to organize and manage technical session within this stipulated. So my first request to all the speakers, please, if they can reduce their time, definitely they have been allotted half an hour, some are allotted 20 minutes. If they can help me in managing this technical session, because after this technical session is only we have to wait for lunch for longer period if the technical session is delayed. So that's my request to all the speakers, honorable speakers. I can understand because they have prepared their talk based on the time allotted to them. So I request, without any further introduction about the session, definitely the session is based on the innovative sustainable practices in vegetable oil industry. So the title is very clear, and all the speakers are eminent speakers in their field. So definitely when they speak, the topic will be introduced itself. So that's I am just sustaining the introduction of the session, and I request the first speaker, Dr. Mark Callan from Global Technological and Innovation Director Desmet, Brussels, to speak on the innovations in vegetable oil processing, moving towards a more sustainable food, oil processing, and oleochemical industry. As you know, Desmet are known for the innovations in vegetable oil industry. So technological innovations, and they have been doing a lot. So I'm very happy that they are here, and I request Dr. Mark to go ahead with his presentation.
Leading innovations globally, we have Dr. Mark Kellen, sir, the Global Technical and Innovations Director of Desmet, Brussels, with years of expertise in oils, fats, and oleochemical processes. He is a key figure in driving cutting-edge solutions. We welcome him to share his insights. Thank you.
So I would like to start with the title you see, Innovations in Vegetable Oil Processing, Moving Towards a More Sustainable Food, Oil Processing and Oleochemical Industry. The most important word is sustainability. Why are we talking so much about sustainability today? Because mankind is challenged by Mother Nature. Mother Earth is suffering from uncontrolled human activity affecting our ecosystems. Population is growing, requiring more and more food to feed them. Also, the standard of living is increasing, which consumers are requiring higher quality products and also more luxury goods. We are depleting the natural resources at a speed that nature cannot compensate. Even globalization is creating in quite some areas, we call it an unhealthy atmosphere, where agreements made are not always respected. There is an unequal wealth distribution, creating more waste and spillage of natural resources. There's inequality in social well-being, is becoming bigger and bigger. And the result is that we are confronted now global warming, which is threatening the environment and the future of the next generations. Climate deals, which are being made to save what's left and to restore what we can possibly restore, are not being followed 100%. And so we as mankind are standing really before the biggest challenge is to become sustainable on all fronts and as fast as possible. Now, when you talk about sustainability, since I'm the first speaker, what is sustainability? It's about meeting our current needs without compromising the ability of future generations to meet their own needs. Sustainability aims to preserve natural resources. That's the first thing, in a way that it doesn't deplete them for the future generations. Sustainability also incorporates protecting the environment, the ecosystems, to maintain natural habits and biodiversity where possible and restore what was lost. Also, sustainability incorporates the promotion of social equity by ensuring the fair distribution of resources across all the communities while respecting human rights, and also it supports the economic viability so that sustainability ensures that economic activities are conducted in a financial, healthy way without long-term negative impacts. So it's all about creating a harmonious relationship between the humans and the environment, promoting practices that are not only beneficial today, but also for the many generations to come. So it's very, but not too late to stop and revert, but time is running out. We need to react now. So what can we do for the vegetable oil processing industry to make it more sustainable? As said, focus on efficiency, efficiency, efficiency. Reduce energy, steam, electricity, reduce consumables. Environment, reduce the air, soil and water pollution. Social well-being, make these processing plants as safe as possible and respect the human rights of the employees. And turn sustainability challenges into opportunities. So, because it's quite known, less of everything always means less cost. So it's an economical effect. And innovation is key because a lot of innovations today focus on improving sustainability are waiting to get implemented. And so they need to be implemented as soon as possible. And it will require more automation, and even today everyone's talking about artificial intelligence. It will help in speeding up sustainability. But also governments have an important role to play. They need to strengthen the policies and regulations to promote the sustainable solutions and practices and ensure that the compliance is essential for long-term sustainability. Now, when you talk about oils and fats processing, you have to understand how big is the market. When we talk about global market vegetable oils, if you see over the last 10 years, from 2014 to 2024, average growth 2.5%. We are today at, if you take these 9 most important oils, we are already at 222 million ton. If you look into the vegetable oil markets, you add also the minor oils, you are around 225 million ton. To give you an idea, India itself produces 12 million ton. Global animal fats is about 27 million ton, Indian only 0.2 million ton. And global used cooking oils, and I'm mentioning used cooking oils, is quite important later on. Globally, estimated around 15 million tons. In India alone, there is a potential of 3.3 million ton. So what is the forecast for the next 10 years? There you see estimates are going from 265 of oil availability today, including the used cooking oils, animal fats, and the distilled grains corn oil. And as the outlook is that we will reach 353 million ton by 2032. Palm oil and soybean will become more and more dominant in the food, but you also see that especially the used cooking oils, the animal fats, and distilled corn oil are typical feedstocks and are now to be scrutinized because they're quite important for producing biodiesel and HVO. Where is that growth coming from? Total oil and fat growth in the next decade, as we said, 88 million tons on total surplus, from which about 70% will go into the edible applications and about 30% going into the non-edible application, being the oleochemicals and the biofuels. 45% of that growth will be linked to the 2 main oils, palm oil and soybean. And so that means when you produce more oils and fats, means you will produce more oil crops and more livestock. Hence, there will be even more pressure on the environment So all that growth should come at a net zero impact. So it should be done in a sustainable way. And that is a very big challenge. When you look into the world consumption, as I said, 70% going into food, 180 million ton. Feedstock for oil chemicals, about 25 million ton are being used for making all the fatty acids, fatty alcohols, the esters, glycerine. And you see that about 50 million ton is going into biofuels. Main biofuels are methyl esters and also HVO today. Waste oils and animal fats, as I said, they are going today more and more into HVO because there are special incentives, and also it is driven by the sustainable factor. Don't use a food oil to produce a fuel. Use a food oil which is not anymore food, and use that for fuel. That is a sustainable activity. So sustainability is important for all these sectors. When you compare the global with the Indian vegetable oil processing market, then you see here, India represents about food oil, about 12% of the total market. In oil and chemicals, about 7%. And in the biodiesel market, India is really lagging behind. It's only 1%, less than 1% impact on the biodiesel market globally. Now, I also have to say, when you look for all these figures on the internet, you have to take these figures also with a certain degree of criticism, because depending upon what resource you use, you can have some fluctuations, variations, but the general trend is there. And you have to look into the trend, not into the absolute figures. So what's the current Indian vegetable oil market today? As you see, 25 million ton is being consumed, but you also import almost 16 million ton. That means more than 60% of all the oils being processed and being used in India are imported. As I said, part of that oil you import is not used for food, but also goes into the oleochemicals. Especially what you see is some and then even a little bit in biodiesel, but most of these oils going to these applications is more polystyrene, part of used cooking oils, some of the animal fats, and also of course the fatty acid distillates. So what is the future situation? Here I made a comparison, the world versus India. And you see that India as such, the growth in production is growing more than the world production. About a 1.7 average growth in production, where the import is growing at 1.1%. So that's already a positive direction, that India is will produce more oil locally. In consuming, as you also see that India is consuming proportionally, the increase in consumption, the growth is bigger in India than on world level. That will mean that India needs more oil, producing but also consuming. And if you look into the consumption per capita, then you see that India is quite lagging behind compared to the world consumption. 10 kilo per capita per year today versus 15, 16 kilo on world level. So the Indian vegetable oil consumption is growing faster, making India even more dependent. Government policies are now being installed to reduce import by stimulating local production, but that will take time. And the problem is that global warming is not helping that conversion. Also, at the same time, consumers are getting more and more concerned about quality of what they eat. And so you have today the whole issue around 3-MCPD, glycidyl esters, MOA, sustainability concerns, which could also impact the import of some of the oils. So when you make the comparison between India in 2023, domestic consumption about 12 million ton, import 60 million ton, total availability 27. These are figures from FAO and OECD. What they project in 2033, that production will go from 12 to 14 million tons, so an 18% growth. The import will go from 16 million to 17.5, a smaller growth than the production, and the total availability will grow with about 14%. Now, what is important? Today, India counts for 1.45 billion people. If you take the 10 kilo per capita consumption, that means actually 14.5 million ton is consumed. That means what is known as being consumed is only 53% of the total 27. Then the first question is, where is all the rest going? Where is that 10 million ton going? When you see what they expect in 33, where they expect that the consumption will go up with at least 10% per capita, population will grow with another 100 million, that then you will have about 17.5 million ton consumed. If you take the same ratio, the 53%, that means you need 32 million ton availability. And that's also what they project, that there will be 32 million ton needed by 33. If India would target the 15 kilo per capita as a benchmark, so cost of living, standard of living goes up, people have more money, they will spend more on food, and that means also there will be more demand for oil. Then if they would achieve that, then you need even 11 million ton more. Then you talk about 43 million ton, which becomes really an impossible challenge. As I said, the latest decision, the government is pushing the local farming industry to grow more oil crops. But as I said, oil seeds, if you grow oil seeds, you need the oil, but what you do with the meal, that will be then the next challenge, because India does not need that much meal. And as I said, climate changes are affecting crop production already in a negative way. So when you look to the oleochemical market, India, these are some rough figures. India represents in fatty acids around 8 to 9% of the total, fatty alcohols about 5%, and glycerine also 9%. In glycerine, for instance, half of the glycerine India is producing, consuming, is actually imported. Only half comes from their own plants. Biodiesel, there India really is very, very, very behind, less than 0.5% compared to the global production. When you focus on biodiesel, as I said, blending rate today, maximum you can achieve in India is 0.3% with the 250,000 ton produced on a total consumed diesel of about 85 million ton. Indian government is targeting B5 by 2030, knowing that by 2030 you probably need 100 million ton of biodiesel, that you need to find a way to produce 5 million ton of biodiesel. How do you do that without jeopardizing the food oil supply? So it's a really big challenge to get that target done. There are ways, because if you look to the oil, which is anymore not used for food, if that could be logistically be collected, there is enough oil to supply oil to that biodiesel. As said, the fatty acids, there's about 500 million ton of fatty acid distillates. Polystyrene, I said polystyrene is one of the products being used also in the biodiesel. When you import 9 to 10 million ton of palm oil, you fractionate it, you get about 1.5 million ton of polystyrene. Used cooking oils, as I said, they are present, but they are not being collected, about 3.3 million ton. By 2030, it will be 4.5 million ton. And animal fats, that remains quite so. There is about 5.5 million ton potentially available for the biodiesel industry. As I said, demand will be 110 million. If we need 5.5 million ton to reach the B5, that means the biggest problem will be the logistic, how to collect all these waste streams. There is this RUCO project from the government to set up a system to collect these oils. As I said, if you would target that, that would mean India needs to build 1 million ton per year additional biodiesel capacity. That's 3,000 ton per day. Take a 75% occupation. As I said, the current plants run only today at 25% of the capacity. So that you need theoretically 4,000 ton. If you take a plant of 500 ton per day, that means 8 plants a year should be built every year only to reach that B5 target. Now, also what I found is quite interesting. Even Indian government today is investigating the use of ethanol in diesel. But that will not be that easy. Because I think you always will need a certain amount of biodiesel, because the biodiesel has a positive impact on the lubrication effect of properties of the fuel. So there are some discussions and some investigations. Could India go for a BE20? That means 5% biodiesel and 50% ethanol, like you have the E20 target for the petrol. So, and the driver of the biofuel industry is bringing down CO2 emission. So to stop global warming, emission needs to go down everywhere. Here you see what has happened in the last 2 generations. we went from, because a lot of people do not understand, do not know how much, when you talk about CO2, what is it? Today, 50 years ago, you had about 0.03% of CO2 was present in the air. Today we are at 0.04. So people say, it's only 100 ppm. But the 100 ppm has caused an increase of the global temperature of 1.5 degrees. Only 100 ppm. And when you see, what you see is that the biggest contributors are China to the global warming, to the emission. The United States are the number 2, India is number 3, and Europe is number 4. Per capita, there, the worst student is the United States. They emit 14 tons per capita. China, 8. China is doing a lot of efforts to bring it down. They are investing a lot in green energy. EU is at 5.6, and India is at 2.3. So India is much lower than the rest, but it's picking up. And you see that in the figures there over the last two generations, that there was a 1,500% growth in CO2 emission. So India has a lot to do there. I said 75% of emission comes from fuels, and the global temperature, I said, in 74 was 1.1 degree. We are now at 1.5. So, as I said, all the models, they said we would achieve 1.5 in 2030. We will achieve 1.5 degrees this year. So, and we need to do all our efforts, because what we share worldwide is one common atmosphere. That's something you cannot put a border on. So how does climate change affect, for instance, our industry? Here, an example. Monsoon, the shift in the monsoon is already have an impact, a negative impact on, for instance, the crop of soybean, where you see that also the oil you recover from the crop has a much higher acidity than it had 50 years ago, which of course means that the refineries need to process that oil, requiring more chemicals, having more losses, and all these things. Also, the global warming will affect the yield. So we see that there is expected that there will be a 10% loss in crop yield by 2050. Research institutes are trying now to develop climate-resistant crops, but we do not know what the outcome will be and how fast it will be implemented. Same thing, for instance, on our processing industry. If you look to the typical barometric water temperature in 2007 was around 32 here in India. In 2011 was 33, and now we already, actually, we are closer to 35 now already. And this has an impact on, for instance, the deodorizer. When you run a deodorizer with a vacuum system, that your same deodorizer is now needing 10% more steam to compensate for this higher barometric water. Of course, there are technologies to revert that. One is now also becoming quite visible in India, is replacing these motor steam-driven vacuum systems by ice condensing plants. And they really have enormous, they have an 80% reduction in steam consumption in a deodorizer, for instance. So, what is the relevance of the CO2 emissions to the oil processing industry? When you produce, as I said, the primary source of energy in India is still coal. If you want to make 1 kilo of steam, you produce about 0.6 kilo of CO2, based on 4 kilo of steam per kilo of coal. If you want to produce electricity, with 1 kilowatt will produce something like 0.8 kilo of CO2, because that energy comes from mixed coal and renewable resources. There are some people saying, but why can we not use simply electrical power and produce steam with that? If you use the steam, the electrical power produced today, and make steam, you emit the same amount as if you use coal. So the only way to go for green steam is using 100% green electricity, but not the steam, not the electricity which is being served today on the grid. In Europe, for instance, we are talking about why not going back into the nuclear as a short term. Yeah, a short term is, yes, because that has the lowest CO2. If you look at on the total life cycle assessment, 1 kilo steam, 0.1 kilo, 1 kilowatt, 0.15. Now, what is very good is the Indian government is doing a lot of efforts in boosting up the portion of renewable energy. 201 gigawatt today, they expect 500 gigawatt by 2030. Will it be enough? That we have to see. So how do we make it more sustainable? use alternative energy source, green electricity by definition, minimize energy, water usage and consumables, use as possible renewable and biodegradable chemicals, use enzymes in places where you can do your catalytic reaction instead of using chemicals, make maximum use of energy efficient technologies already applied in the industry. For instance, we are today investigating a lot of use of heat pumps in our industry. Mitigate waste streams and reprocess them so that they become environmentally neutral, and of course think more about life cycle assessment instead of a return of investment when going for sustainable technology. Because sustainable only pays on the long term. As I said, some advanced technologies to reduce chemical, steam and power. In chemicals and adsorbents, there are various technologies, hydrodynamic cavitation, improved bleaching systems, filtration systems, steam consumption, reducing technologies like more efficient deodorizer with packed columns, very efficient ice condensing plants, the use of continuous project process instead of batches like continuous fractionation, and of course also reduction of power can be, when you go from batch to continuous, you have usually a lower power consumption, and some of these new generation mixing systems also consume much lesser power. As I said, all refining developments from quality to efficiency to sustainability. Here are examples. I will not go into detail, but I only want to give you an example. Case study 600 ton per day. If you look to a conventional plant and to an approved, even small incremental savings have a big impact on an annual basis. In this case, as you see, phosphoric acid, 80 ton per year less. Caustic soda, 120 ton per year less. Bleaching earth, 300 ton per year less. Steam, 17,000 ton per year less. Power, okay, you compensate power, but if the power is green, it's not a problem. Oil loss, 500 ton per year less. So, to see what can be gained on for a particular plant will depend on what technologies are being implemented, and it will require a pre-engineering in order to study what could be the gain. Same thing for fractionation, for instance. When we go from continuous, you see there, throughput, yield, steam, power, filtration, everything is going down. Same thing when you look into a refinery and a fractionation for palm oil, because you import 10 million ton per year of palm oil, you see also annual savings can be tremendous if you pay attention to every consumable and every action which can reduce your cost, but at the same time improves your sustainability. Biodiesel, same thing. There are a lot of improvements today possible to improve the heat recovery, improve reaction efficiency, reduce your catalyst, improve methanol recovery, improve the waste stream processing, and at the same time, improving the quality. Also here you see, for instance, an example, also small incremental savings have a big impact on the annual saving and has a big impact on the carbon footprint of such a plant. As I said, the fuel also market is requiring better quality biodiesel to allow higher blending rates. Also, people are thinking, do we need then to install distillation plants? No. Companies like Desmet are developing technologies where you try to improve the process while reducing at the same time the carbon footprint. So, as a result, you know, the three main sustainability drivers are reduce, reuse, and recycle. Our industry, I say, we have to opt the triple E approach. It's make the plants as efficient possible by trying to save where you can. It will help you to become more profitable, but do everything with respect to the environmental impact. You need to reduce the environmental impact at the same time. So, as a result, conclusion, what to do to improve sustainability for the Indian, but for the world. Move away from coal-heavy fuel. Make the power grids more reliable. It's also very important because every shutdown of a plant is a cost. Run the plants more continuous, so and lower the shutdown times. Go for higher quality technologies in equipment as they last longer and are more reliable. Install high efficient vacuum systems, as mentioned, ice condensing. Increase heat exchange recovery by installing more performant heat exchangers. Use waste heat, that's for instance a topic we are doing now. Any waste hot stream we have, we can direct to heat pumps. So we can generate steam from it, which you can use in the plant. use the latest technologies to mix, so to lower chemical consumption, and also maximize the use of soft process where possible, meaning use enzymes to compensate as an alternative to chemicals. I said again, we talk about reduce, reuse, recycle, convert any waste into wealth, as we call it. Think more in terms of LCA instead of ROA, so life cycle assessment. Look on what a plant can bring on the whole life cycle than only on what it should bring in order to have a short return of investment. And think what can be done today to save the future for the generations to come. Because sustainability is not a wish, it's a mission we owe to our children. Thank you for your attention.
Thank you, Dr. Mark,
The
for
questions
helping
later on.
me. Yes, yes, yes. If you have any question, we can take one question at a time with one speaker, because later on we have time constraints. So later on during lunch, you can discuss with the. We can take one question, for Dr. Mark, if anybody is having any question. Thanks, Dr. Mark.
Okay,
Please.
thank you.
Our next speaker is Mr. Prabhat Gupta, Prabhat Kumar Gupta rather.
Thank you, Kellen sir. Now, we welcome Mr. Prabhat Kumar sir, Regional Product Manager for India, South and East Africa at GEA Westphalia Separator Group, Ulde, Germany. His contributions to the process engineering and product innovations have been instrumental in advancing the vegetable oil industry. We welcome you, sir.
Thank you, friends. A moment, please. Please be patient with me, my system is booting. First of all, very good afternoon to everyone. Excuse me. Yeah, it's loaded now. So very good afternoon to everyone, and first of all I congratulate Dr. Praveen and his team for organizing this international seminar on focusing on the sustainability in oleochemicals and vegetable oil processing industry. Before I deep dive into my topic of innovative and sustainable solutions for edible oil refining, I would like to remind very critical, just, I would like to highlight some critical aspects about the human environment and the climate change. Of course, all these facts are known to us, but I really reiterate and remind to all of us, because we are in a situation where do now or never. The situation regarding the greenhouse gas emissions, Dr. Mark was already talking about 100 ppm of carbon dioxide is leading to already higher temperatures in the environment. So it's really very important to understand the science behind the global warming. And even after passing of 50 years since the first sign of climate change was scientifically established based on the carbon dioxide level, still we are lacking in the significant actions to limit climate change until recent past. We have seen some changes, but we have to really remind ourselves it's really we are in difficult situation. Yeah, it was 1965 when the research studies provided the estimate of global warming based on the CO2 levels. And the first global conference on the human environment was held in 1972 in Stockholm, which is a milestone for the United Nations conferences on human environment, climate change, and related topics. Thereafter has been many UN conferences on the international, on the environment. However, the main ones are in 1992, the Earth Summit, and thereafter Rio Plus 20 in 2012. And importantly, in 2015, there was a Paris Agreement signed by 196 countries, and it was pledged that the increase in the global average temperature to well below, we have to keep our global temperature well below 2 degrees above the pre-industrial levels, and pursue efforts to limit temperature increase to 1.5 degrees centigrade above pre-industrial levels. However, please note, the limit of global warming to 1.5 degrees centigrade greenhouse emission must peak before 2025. That means as we speak, we should have done it. And the deadline to reduce the emissions by 43% by 2030. But let's see what is actual position. And if we see the Sustainable Development Global Report of 2020, which is very alarming, it says progress remained uneven and we are not on track to meet our sustainable development goals, that is SDGs, by 2030. And again, the situation is not really improving. If we see another reports, in 2022, the UN climate report says, they made public to world community, is very clear that we are in do or die situation. It is now or never to act to limit global warming of 1.5 degrees centigrade. This is really challenging. And another report of UN report in 2023, which states the effects and threats of climate change to millions around the world, with rising sea levels and very existence of coastlines endangering nations and competition over natural resources. Incidentally, I was traveling yesterday from Delhi to Kanpur for this conference. I could get over the Economics Time, and there was on an editorial page, there's a country which is very tiny country in the Pacific Ocean, and they are inviting and they're giving citizenships to people to come to that country. And but there's a challenge is that whether, and it's a beautiful country at the very nice sea coastline, but there's a caveat, whether when all the papers will be processed for the citizenship, whether these coastlines will exist or not. These are real challenges what we are facing. Similarly, in Delhi, we have never experienced high temperatures in Feb, which is already 34 degrees plus. In Feb, 26 recorded highest temperature in Delhi, 34 degrees Celsius temperature. And last year, we already touched more than 50 degree temperature, which is quite alarming. The situation is really difficult, and we all have to act very judiciously to use our resources. And recently we have a Mahakumbh Mela, and the UP Chief Minister Adityanath Yogi had a declaration which is called Mahakumbh Declaration on the Climate Change, which highlights for the green actions. That means all our shrines, temples, they should go for green options. What I mean to say here, all these history points us to us that it's high time to act collectively and individually to invest in right technologies to save our planet, ourselves, and our future generations. So this is a real threat for our own survival and existence. So we have to really decide right kind of technologies, whatever the business we are in, how we can really contribute to bring down the greenhouse gas emissions. Yes, I'm representing GIA at this moment, and I will talk about the GIA, what is doing to make our sustainable goals. The GIA climate strategy is, GIA is leading engineering and technology company that has ambitious targets to achieving net zero by 2040. I was hearing, I don't know whether I missed it, there's a speaker from the Unilever, but I could not find what is the real target of Unilever to get the net zero emissions level. That's very important. We all are talking, but we have to really challenge ourselves to set targets ourselves to become a net zero by whatever the target. Of course, if I'm correct, India has a target of 2070. And as GIA, as a company, we have set targets for 2040, which surpass the EU standards, which is 2050, and Germany itself, it is 2045. So, I mean, we have to really contribute in whatever possible way to have less gas emissions. Let's see what is our GIA climate strategy to reduce greenhouse gas emissions is to implement our leverage at every link of value chain, which are taking the public stance. That means we are committed to raising public awareness of climate protection and playing an active role, sharing our experience and expertise, and taking others along with our journey. Even we have guidelines for our suppliers. That means we want our suppliers to define their own SBTI validated climate targets. That means these are science-based targets. So even we are asking our suppliers, and we are preferring to them who are working on this sustainable aspects. And of course, we have to see our operation itself. How we conduct, that means all indirect and direct emissions in our operation, we are working on it. And of course, we are transforming our product portfolio. I mean, we have a control in our operations, how we conduct ourselves, and we know our product. So we are really transforming our product portfolio, which are more efficient in energy and resource consumption. So this is the way we are going forward to meet our net target commitment to zero by 2040. Of course, by 90% we will do with our indirect and direct operations. 10% balance will be done with the absorption of the carbon from the atmosphere. So that is how our strategy, and we are really committed to do as our corporate culture. So these are some milestones. We started 2019, and we have milestones 23, 26, 2030, and 2040. These all targets are based on scientific science-based targets, which are validated by the agencies. And last, I mean, in pursuit of this climate strategy, GIA launched a better label for GIA products. That means we are coming up with a label on our own products, which is better and more sustainable solutions in comparison to our previous machines or the processes what we were offering. So we are challenging our own product, and we want to make more sustainable so that we can contribute to our customers in reducing the carbon footprint. They add better level and yeah, hello, yeah, you can, I'm audible? Yeah. See, they add better level, identifies solutions that are significantly more energy and resource efficient than our previous generation of machines. These solutions reduce the consumption of resources such as energy, water, and we generate less waste. So these are our motives. These are calculated on the basis of recognized methods and then validated by German Technical Inspection Agency, TUV, Rhineland, that's a German agency. And of course, we are working with the ISO standards. So, I mean, this is a commitment from our corporate that we have to be sustainable, not only in our operations, but also our solutions to the industry. And of course, we are well recognized for our efforts by various rating agencies, which are many on the slide. And here I would like to really give another very good example of how we are committed to course, there's no slide anyhow. GIA is the only German company in Dow Jones Sustainability World Index for machinery and plant manufacturing sectors. This is the only German company which are in this Dow Jones Index, which is really a group of companies who are really acting and working in the direction of sustainability. So, yeah, this is our CEO, Stefan, and he is very clear in directions for our sustainability targets, what it achieve. Now let's talk about, of course, this was the brief. Somehow this topic is very close to my heart, and I wanted to give a feel that we are really in pain at this moment. And that's why I was done through the whole history and how the global warming is taking place, and as 100 ppm of carbon dioxide is really giving havoc. And we are already 2050 at 2025, and all goals are haywire. I don't know what is coming up. So let's talk about what the innovative solutions we are offering here. Of course, one is that we transform our own product lines, which are more energy and resource efficient, and which positively impacts our own and our customers' greenhouse balance. So this is our commitment. And other is we have to improve our process efficiency. Of course, our separators are used for the oil processing industries, and we have systems which improve efficiency of the refining plants, which consumes less utilities. So these are the two areas for us to talk about, but I know we have less time, then I will only focus on the machine part, which we are transforming. So I will just talk and restrict on that. And GIA, we are making these machines over 100 years, and we have seen all changes in the machine and the drive part. So I will focus today only on the drive part, which we have developed in recent past than previous generations, which are efficient and in energy consumption. Let's see and how the drives of the separators evolved over almost 100 years. We had in 1930s where we had gear drives, then came belt drives. Of course, it took 50 years to come up with a new solution. Probably that was not a challenge experience that we have to work on the efficient systems. Then we have come a drive which is direct drive in 2003, and then we came up in 2009 with the integrated direct drives. Of course, all these drives are differing to each other in terms of design, working, maintenance costs, and energy efficiency. And now we have the latest drive, which is integrated drive, to offer. And let's see how the efficiency improved over a period. The gear drive gives about 84% of efficiency, and then we have flat drives, 89%, and the direct drives were 94%, and integrated direct drives, which new generation what we have, which I'm going to discuss, is 96%. These are the best in class drives for the separators in terms of the energy consumption. And I'll just, and of course, another point which I would like to say, we had the integrated direct drive, which is RSI machines, but these was only in the large size of plants. That means anything which starts from 350 tons to 1,200 tons per day capacities of refining. But I'm happy to say that we have introduced this concept of small machines, which is really apt for our Indian market, which is for 100 and 200 tons capacities. I'll just give the design concept of these machines. These are termed as RSF 40 and 80 machines. 40 is for 100 tons per day capacity, and 80 is for 200 tons per day capacity of refining of soybean, any soft oil for that matter. Look, there in the machines we have two areas. One is the process area, which is the bowl, where the separation actually takes place, and other area is the frame, where the drive, which drives the bowl, which does the separation. So we in the new machines, our process area is same. We have done nothing on that so far as we speak, but we have really transformed our drives even for these smaller machines. And of course, this drive is comprising of spindle, bearing, and lubrication and terminal box. And let's see how it differs. This is the internals of the machine. This is the drive, which is, spindle, and the motor is housed in the frame. That means we have the motor, spindle, everything in the frame, and the lubrication unit. So, and we are, of course, we are using synchronous motors with the permanent magnets, spindle bearings and lubrication, and the drive benefits are no cooling water, because if you're larger size of machines, we have a cooling system to keep the oil cool, but for these smaller machines, we have designed this drive where we don't have even the cooling water for keep the drives cooler. And there's no external lubrication, and of course, as we discussed, we have a highest possible efficiency for motors, and of course, we have the patents for these drives. And we have another come up, as we talk about how we have to achieve to 2040, we are so particular even how we as the employee of the company commute to the office. I mean, everything is so designed well, and on that basis we have come up with a new service concept which I have never seen in our industry, this concept. We have come up with a drive concept where it is a complete exchangeable drive. That means we have no maintenance on the site. One has to come with the drive and just place it. So this is a fairly, I'm running out of time. I'm asked to really wind up. I have to rush with my slides. So this is really a concept which we have not seen in the industry, and we have already supplying these machines, and I'm pretty sure by end of this quarter, we have these machines running in our country. And these are the first of the machines we produced so far in this small size. I'll just skip some and just give a video, a short video which give the brief, the idea how the service concept is innovative and not as is done in the past. This is the machine we are talking. Of course, we have done some modifications already on that. Yeah, here comes the complete exchangeable drive. So this is, I will skip, and of course you have to just unplug, you have to take out the three wires, take out this drive completely and put a new one, which is a refurbished coming from us. So this could be the best possible, even we don't require highly skilled manpower. Even I would say going forward, probably we don't need our service engineers visiting to this site for replacing these drives. The customer can do, which is very important in terms of the availability of the machine and the service cost. I mean, I would say up to 99% of the machine is available for the production. So just give it, I will say my last slide, I'll just finish it. What this new machine offers to us. This our first drive, direct drive for the small, as I already said, RSF 40s and 80s with the high speed running separators. These are energy efficient, cleaner, quieter, less downtime, and smaller footprint. Even we have a very smaller footprint than our previous machines, which were the belt drives. I would say we save about 50% of the civil work with the smaller footprints, and of course with the accessible drive concepts. And what key benefits offers this new drive is up to 10% of energy less, 10% we save on the energy consumption, more machine uptime. As I said, it is no much time to change the drive, which we recommend maybe 6,000 hours it has to be replaced. So this is typically available all the time. I would say with maximum 2 hours we require to just replace the drive. And of course, it's a less noisy, proven drive concepts. There are no prototypes. We're talking about the real machines in the market. And of course, the machine what we are offering for the oil refining business has no rib bodies. In all the motors have the ribs, but these are no ribs, and there's very hygienic design. Last, the target group, which is very important for me, and I wish we have to think about it, is this machine is really ideal for the customer profile who are interested in the new technology. It's not just for the sake of new technology, which really adding to sustainability and reducing their carbon footprints, and that's from my side. I mean, we as a company are committed to bring to the zero emissions by 2040, and we are transforming our operation, and as well as we are transforming our own product portfolio. I mean, this speaks about the commitment. This is all from my point. If any questions are required, then I mean, I answer them if there are any. Otherwise, I'm available until tonight. I can be caught any moment. Thank you, sir. Yeah, please. There's a question. Pardon? What is the integrated drive? The integrated, basically, if you see, let me just take one slide which give a real. Yeah, you know, if you see on the top, there's a drive which is a belt drive machine, where we have a spindle, motor, and this is running with the belt. So that means we have the lateral tensile forces, and we have more bearings. On the vertical shaft, we have the bearings to support motor and the spindle of the bowl. And we have another bearings from the motor side. So we have done away with all bearings from the motor side. There is no gears, no belts. This only, we have the bowl sitting on the vertical shaft, and we have only two bearings in this machine. One neck bearings bearing, and one is the support bearing at the bottom. So we have less bearings, more reliable, and there are no lateral forces acting, because it is just sitting on the top of the spindle. I mean, motors and the machine spindle is one. That's how it is being. And of course, all frequency driven machines. Frequency driven.
Okay, thank you, Mr. Gupta. I think you can discuss later on.
I'm
Yes.
available.
During lunch, you can discuss.
Thank you very much. Thank you for patient hearing.
Thank you, Prabhat Gupta ji. Yes, thank you. Okay, we go to the next speaker in the line, Dr. S.K. Raja, CEO Testing Fair Labs. The topic is role of proficiency testing, reference material, inspection and certification in quality management. Along with Dr. Raja, there are a few more contributors in the presentation whose name are mentioned. Yes.
Well, Honorable Chairman, Co-Chairman, and then invited speakers, faculty and students from HBTU. First of all, I am thankful to the organizers and of course to Fair Labs for giving me this opportunity to be here with such an august gathering and at such an prestigious institute or university. All of you might be aware that today everybody is talking about the quality system, and the topic of sustainability, in my opinion, sustainability cannot be there without quality. So we thought it worthwhile to address or discuss about the quality system and the contribution of Fair Labs in particular to meet the quality management system. What is quality management system? It is the process of overseeing activities to ensure a desired level of quality, and it involves planning, creating and implementing quality assurance control and improvement. At its core, quality management system is a business philosophy that champions the idea that the long-term success of a company or organization comes from customer satisfaction and loyalty. And of course, you have to meet the regulatory requirements also. QMS requires that all stakeholders in a business work together to improve the process, products, services, and the culture of a company or organization. And for meeting quality systems, the International Organization for Standardization, that is ISO, has brought out lots and lots of standards and guidelines so as to meet the international requirement by the organizations, by the companies, by the laboratories, and so on. So a lot of ISO standards have come up. I'll not go into the detail. Fair Lab is accredited and certified for many such international standards. We are accredited as per ISO IC 17025 for testing. We are accredited as per ISO IC 17025 again for calibration. We are ISO IC 17043 certified as a proficiency testing provider, which I will take up in a bit detail. We are also ISO IC 17020 accredited as an inspection body. We are inspecting the food establishments, the hotels, restaurants, dhabas, and so on for hygiene rating audit and for third-party food safety audit also. We are also going for accreditation as per ISO 17034 as a reference material producer and 17021 as a certification body. Again, our main thrust is on food. So FSMS 22000 we have taken food safety management system. So what is proficiency testing? I'm leaving the testing and calibration. Most of you people may be aware. I'm taking up proficiency testing, which Fairlab is a PTP as per ISO IC 17043. Proficiency testing involves the use of inter-laboratory comparison between the laboratories, various laboratories, for the determination of laboratory performance. And it is a mandatory requirement, almost mandatory requirement I should say, for accreditation as per ISO IC 17025. If any lab wants to enter into the testing or calibration area, they have to participate in proficiency testing by a PT provider which is accredited as per ISO IC 17043. It can be used to provide independent demonstrations of laboratory competence. So proficiency testing Z score is given, and having a good Z score determines the competency of a particular laboratory. The requirements of this international standard, that is ISO IC 17043, which has come recently as 2023 version, applied to many of the technical planning and operation activities. NABL provides accreditation. Of course, there are two private organizations also have come up, but NABL, National Accreditation Board for Testing and Calibration Laboratory, which works under Quality Council of India, Government of India, Ministry of Consumer Affairs, Government of India, gives accreditation as per ISO IC 17043, and you become a PT provider. So international standard specifies various requirements that are required by the PT provider to be followed for becoming a PT provider. Fairlab offers, and this is the only laboratory which has in its feathers, we are providing PTs, proficiency testing, in both testing as well as calibration area. There is no laboratory in the country as on today which is providing proficiency testing in both testing as well as calibration. Again, in testing, we are offering in chemical, biological, and radiological. Again, I would like to emphasize that radiological testing is a regulatory requirement by FSSAI and DIC for both food and water. And in India, there are only a few laboratories which are offering testing, proficiency testing for testing of radiological nature. In calibration, we are accredited for mechanical, thermal, and electrotechnical disciplines. This is the scope of PT provider, that is Fairlabs. We are doing in chemical field, biological field, molecular biology, radiological, and of course calibration, which is thermal, mechanical, and electrotechnical. We have a big scope. Actually, we have the largest scope in the country as PT provider. And this is the certificate that we got. As I told you, it has been revised. The standard has been revised in 2023. We are accredited as per ISO IC 17043, 2023, and our validity is up to September 2026. I'll not go into the details. There are a lot of advantages of participation in PT. As I told you, one big advantage is that for any accreditation as per 17025, you have to participate in proficiency testing. So due to dearth of time, I'm skipping that. If anybody is interested, I can give the details maybe in lunch break or in the evening. Then second accreditation which is required for 17025 accreditation is production of reference material, RMP it is called, RMP it is called, reference material producer. This accreditation is again granted by NABL, National Accreditation Board for Testing and Calibration Laboratory, and the standard is ISO 17034, 17034. We are not yet accredited for this, but we are in the process of submitting the application. We have started with, heavy metals are contaminants in food and water. And for identification of these heavy metals in food or water, you need reference standards for these metals, particularly the heavy metals or the toxic metals such as mercury, cadmium, lead, arsenic, and so on. So we have started with this project in collaboration with CSIR, IITR, Lucknow. They are producing these standards and we are doing homogeneity, stability. A lot of studies have to be done to submit them to NABL for the grant of accreditation. So we are in the process of getting this accreditation also. Why CRM is needed or reference materials are needed? To ensure the accuracy and reliability of the analytical data. We compare with the CRM. CRM has known characteristics, known qualities, known concentrations, and we compare the sample in question, whether it's a food sample or a water sample, we compare them and we finally arrive at that this is the right metal that is available or that is present as a contaminant in food or water. A good reference standard has to meet a lot of specifications. It has to be homogeneous, it has to be stable for a long time of period. We have to conduct short-term stability, we have to conduct long-term stability, we have to conduct transportation stability, because these chemicals have to be transferred. Maybe to somebody interested in Kerala, maybe calling us to provide some a particular CRM. Somebody in Assam may call us to give. So since in India, the environmental condition, even abroad, the environmental conditions vary, so we have to do a lot of activities to certify a reference material meeting all the qualities or all the requirements. So in India, of course, as I told you, NABL provides again accreditation as per 17034, 2016 version is there, and it is intended for the use by RMPs in the development and implementation of their quality system for the production of reference material or certified reference material. The main difference between a reference material and a certified reference material is that a certified reference material gives measurement uncertainty and it has traceability to national and international standards, which is not a mandatory requirement for a reference material, simple reference material. So Fairlab, as I told you, we are producing reference material or reference standards of metals to begin with. We have a long-term planning for going for other, because as on today, most of the reference standards, whether it's pesticides or antibiotic or mycotoxins, we have to procure the CRMs or RMs from abroad. And we are spending lots and lots of foreign currency in getting this. Even only Fairlabs spends crores of rupees in getting all those reference standards from abroad. These are the 8 metals that we have started with. There are a lot of benefits of having reference materials and CRMs. As I told you, Fairlab is also an inspection body as per ISO IC 17020, 2012. So the term inspection, as all of you might be aware, in simple terms refers to a conformity assessment based on defined and general requirements. The products, that is machines or devices or processes or installations, equipment can be inspected, but we have got accreditation for the inspection of food establishments as well as food manufacturers or hotels. So there is a scope called IAF 03 and IAF 030, IAF 30 for which we are accredited. This is our scope, simple scope. Some of these material, as you see, food and agriculture products, recently FSSAI has made it critical supplies, and those critical things have to be inspected periodically at least once in 6 months if they are producing or they are catering these products such as fish and fishery products, meat and meat products, then dairy products, eggs and egg products. So these things, any establishment serving these things, catering these things or manufacturing these things has to undergo inspection as per FSSAI norms at least once in 6 months. So we are conducting all these inspections. We are also conducting HRAA. We have been certified by QCI as Hygiene Rating Audit Agency also. This is the certificate. This accreditation is not granted by NABL. It is granted by another organization in QCI. It is called NABCB, National Accreditation Board for Certification Bodies. So we got accreditation up to, we got it in September 23, and it is valid up to September 2026. We have also applied for accreditation as a certification body. As I told you, we are highly specialized in food safety and food security related activities. So we have gone for a lot of certifications are there, security certification, management certification. One of them is food safety management system certification. So we have applied for food safety management system under ISO IC 17021 guide of ISO, and the application is under process. Of course, the assessment has already taken place, and we are eager to look to get this accreditation also. NABCB, like NABL, is also ILAC and APAC certified. So once we get FSMS certification, our accreditation will be recognized by world over, because NABCB is having MRAs with ILAC, that is International Laboratory Accreditation Cooperation, and APAC, that is Asia Pacific Accreditation Commission. So since NABCB, NABL both are having MRA with these organizations, so any certificate or any accreditation granted by NABL or NABCB become an international event. So we are internationally recognized for these things. We are in the process, as I told you, FSSC 22000, and this is our scope, of course. If anybody is interested, they can ask me, they can get it. So to conclude my talk, because Chairperson Sahab specifically mentioned that Dr. Raza, you have to finish, and I'm trying to finish it in less time than the actual allotted time. So a quality management system is a structured framework that defines and documents an organization's processes, procedures, and responsibilities for achieving quality, policies, increase efficiency, and improve customer satisfaction, and of course meeting the regulatory requirements. That is very important. One important contributors to the quality management system is accreditation of laboratories as per various standards that I have shown you, and Fair Lab, I think, is unparalleled in having so many accreditations and certifications from the accreditation bodies, that is NABL, NABCB, and so on. Fair Lab is offering quality services to the national, international community. We have more than 8,000 customers for testing, calibration, inspection, and all those things. On a continuous basis, we are conducting hygiene rating audit agencies of audit of the hotels and restaurants and food products in various, on behalf of FSSAI as third party food safety auditor also. So thank you very much for your patience, and if there is any question, you can ask me now or during the lunch break.
Thank you, Dr. Rajab. Completing the talk within stipulated time, I am thankful really for that. Any question? One question can be taken up in this session. Otherwise, you can discuss during lunch.
Not directly
If
related
no question,
to oils,
then
not
thank
directly
you very much.
related to vegetable oil or oleo. No, not directly related to vegetable oil or oleochemicals, so I don't think there is any question.
That's true. Thank you, Dr. Raja. Yes. Our next speaker is Mr. Radhe Kaushik, Commercial Head, Technical Industries, South Asia, known. Along with Mr. Kaushik, Mr. Sudarshan will be aiding in the talk. So there are two speakers on the same topic. So I request Dr. Radhe Kaushik to go ahead with the talk. Definitely his topic is biosolutions for oils and fat processing industry, transforming challenges into growth opportunities.
A very good afternoon to everyone, and thank you organizing committee for giving this opportunity to talk about the smallest element which exists on the earth, that is nothing but enzymes and microbes. So I was sitting across to Trivedi Sahab and he was mentioning here, be very quick. So in that manner, I'll try to be very short, and let me just directly jump to give you a small background, small background about our company, what exactly we do, how we do, and what are the solutions that we can unlock together with our partners and customers. So we are a Denmark-based company, a biotech company, who believes, who guided by the purpose, better business with biology. And at the same times, we believe the nature has given all the solutions that can be solved, that can be given to industry, which can be solved through the natural way. In terms of number, when we talk about 10,000 dedicated people who are working across the globe with an expertise spanning in 30 different industries. We talk about with our collaboration with our partners and customers, and today we are customers and partners are really taking benefit with these biosolutions. When we talk about the global footprints, we have a global footprints of about 45 countries. With that, we are collaborating and doing something different in terms of better life and the better planet for our people. R&D is something which is very close to our heart, and then when we talk about over the centuries that no one else have been pioneer in developing products, we are having a dedicated 2,000 people who are working across the globe, first dedicated to the R&D, and this is the backbone of our company. We are the few company who spends almost 10% of our revenue back to the R&D, and that's how that you can see the number is 9,000 patents. So you can easily correlate The 10,000 people, 10,000 patents. So practically one employee of the Novonesis is actually holding one patent across with them. And when we say the things, any innovations or any new development will be valuable only when we are able to pack it, when we are able to scale it, when we are able to spread it out. So we have approximately 23 manufacturing sites. One already exists in India, where we produce almost 250 metric tons of enzymes and microbes and selling to various industries in India. What we do exactly? We actually make enzymes and microbes. Everything in the Novonesis starts with very tiny, and we try to utilize the power of these tiny particles, which are nothing but enzymes and microbes, to scale and better use of for the industry purpose. As we say, microbiology, it's a biotech company, it's a science-based company. It is in our heart, and then we try to support our customers and partners by taking those and leveraging those natural engineers, which is we call as the enzymes, to convert those and accelerate those reactions in a faster and much more sustainable way. I have a small video just to give you when we say these tiny particles, they really have a power to change the world in terms of creating a healthier life and healthier planet. And this is what we exactly do in our business. The 46% of our business actually goes to creating a better, healthier life in terms of food, supplementary dietary things. And at the same time, the rest of the 54% also goes to the farm, industries, and the home cleaning. And this is what, in the nutshell, that what we do in Novonesis. Now, I think that today's topic mainly dedicated to oil and fat industries, and there I would like to invite our colleague who's a technical expert, and then he will be taking us through what is in it from the Novonesis for oil and fats industry.
Thank you, Radhe. So before I start talking about biosolutions for oils and fats industry, I'd quickly like to touch upon what do oil processors look for. Now, based on our experience with customers across globe and our stakeholder globally, what we were able to narrow down to three key important factors. The first is operational efficiency, and we have heard speakers talk about operational efficiency. Now, the oil processor want more from less. What I mean by more from less is they want more yield, they want high purity products at an optimized operational cost. And that's why they are looking for solutions that help them in saving operational costs, let's say by reducing the energy consumption or eliminating some of the raw materials or chemicals in their process to become more sustainable, or by making their operation more simplistic. The second is feedstock availability or flexibility. So currently we are in a place where feedstock availability becomes a very key challenge in our industry, and There are due to many geopolitical situations and different conditions globally, there are constraints towards availability of feedstock easily. So it's very important that the oil processors are able to find feedstock that is available locally, especially for biodiesel industry, and are able to use it at an affordable price. And the third is moving towards more sustainable and cleaner, greener process. So now more and more oil processors are looking forward to reduce the use of chemicals to meet the standards of the market, meet the stringent standards and set by the government or the regulatory body. Now how do we achieve this? And the answer is enzymes. We'll look how enzyme help you in terms of achieving all these in different application across oils and fats industry. So enzyme has its application across the value chain of oils and fat industry, starting with oil extraction. You can see that enzyme helps in rupturing the cell wall of the FFB to give more oil, thus increasing the yield. So in palm oil extraction, we have seen yield increase up to 1%, then followed by biodiesel. In biodiesel, enzyme helps in both the esterification and trans-esterification process, which helps in providing you feedstock flexibility so that you can use feedstock that is available to you at an affordable price. This also helps in reducing the energy consumption, and that's why it's very beneficial. Then we come to degumming, where enzyme helps in increasing the yield by up to 2%, and at the same time it also enables physical refining. The byproduct created by enzymatic degumming has more value in the market as compared to the byproducts created in conventional method. The next, we have interesterification, where enzyme catalyzes the interesterification reaction, thus helping in creating trans-free vanaspati, margarine, shortening, and bakery fats with a safer and simpler process. So it also inhibits the production of byproducts, because of which you see a higher yield, and at the same time, by possible elimination of bleaching, it also helps in reducing the energy cost. And next we have specialty fats. So enzyme supports in creating very structured lipid. So if you look, there is a high demand for cocoa butter, but due to shortage of cocoa in the market, it is very difficult to create that texture and create that mouthfeel. So enzyme helps in creating structured lipid that is cocoa butter equivalent, which gives a similar texture and similar feel as cocoa butter. So that is where enzyme can help you. And if you come to oleochemicals, now we see that more and more oleochemical manufacturers are using enzymes in their production to increase their throughput and at the same time yield. It also helps the oleochemical manufacturers to move towards more sustainable and greener process, which is the current demand from the market if you look at the personal care side and if you look at the home care side. Now we'll talk in a bit detail about three segments, that is degumming, oleochemicals, and biodiesel. So if I talk about degumming, the purpose that enzyme solves in this segment is increasing the oil yield. Now how it does it, if you see the oil, it has phospholipids that also is known as gums. It has three components, the glycerol body, the fatty acids, and phosphoesters. Now in conventional degumming method, what happens is phospholipids is separated via aqueous phase. The emulsifying property of phospholipids also carries oil along with them, and because of which we see a higher yield loss. So the yield loss in this category, in this method, is that phospholipids take 40 to 50% of the yield, oil yield along with them, and that's why there is a huge yield loss. Whereas in enzymatic degumming method, there are phospholipase A1, phospholipase A2, which cleaves the fatty acids from phospholipids. The fatty acids remains in the oil phase, whereas the lysophospholipids goes in the aqueous phase and is separated. Now since the volume of lysophospholipids is less, that's why the oil loss that happens in this is less. And similarly, for phospholipase C, it removes the phosphoester and it goes into the aqueous phase. It's separated out in the aqueous phase, whereas the diglyceride, it remains in the oil space. Since the volume of the phosphoester is less, so the yield loss in this scenario is less. The benefit of enzyme in this segment, you get a higher yield because of less volume of bigum separated out and carrying less amount of oil with them. You get more value bioproducts. The fatty acid fetches a higher value as compared to phospholipids. You get consistent degumming process, whereas the peak content is so less that the downstream process or the next refining process is very smooth, and as a result you also save on the costing. Now I'll quickly talk about oleochemical. In oleochemical, lipase performs basically three reactions, that is hydrolysis, esterification and trans-esterification, and based on the condition this can be also reversed. Now what happens in conventional oleochemical manufacturing is that there are many side reactions because of the chemicals present in it, and as a result there are many byproducts that is created, which leads to yield loss. Whereas if you see the lipase working, it acts directly on the 1,3 position. As a result, the reaction is very specific and there is inhibition of byproduct, very less byproduct is created, and as a result you see that there is a yield increase in oleochemicals. At the same time, the operating conditions for enzyme is very mild. It operates at up to 70 degrees C as compared to between 100 and 200 degrees Celsius for conventional method. So it also helps in saving you energy cost. In fat splitting, the enzyme does a pre-splitting where it already hydrolyzes the water and oil immiscible liquids so that the energy requirement or time requirement for this process becomes less. Now quickly coming to the biodiesel. Biodiesel is, before I talk about biodiesel is something where we'll see exceptional growth in future. As of now, biodiesel is following the path of ethanol blending in India. So if you look at ethanol blending 2 decades back, there was a target of 20%, but we were not doing much. But it started 6 to 7 years back. In 2017, the ethanol blended rate was around 1.7%, but if you see currently, it is around 17 to 18% already blended. So the government had an ambition of reaching 20% by 2030, but with the growth trajectory that ethanol blending is seeing, it's already around 17, 18, and the revised policy based on biofuel policy, they have reduced the target to reach 20% by 2025/26. So it has a very huge growth, and from the same biofuel policy, we also have biodiesel, which has not seen its full potential as of now, but is expected to reach there, and it will follow the footstep in future. So in biodiesel, in the conventional process, there are two ways to manufacture it. First, you use a low FFA product, and then the operation process is very simple, but the price for the low FFA products are very high and its availability is a question. So you don't get the flexibility to run your plants continuously. Whereas in the second process, you can look out for feedstocks that are of high FFA level, but then you have to do multiple additional processes such as glycerolysis and deacidification, then followed by distillation at the end to achieve this. This makes the operation complex and also creates multiple byproducts, thus reducing the yield. It also requires a lot of energy in terms of running all these operations. Now the quick answer for this is enzyme, where it gives you benefit of both the conventional method. In this, you can use feedstock of any FFA level. It can be from 0% to 100%. At the same time, you don't require additional process of glycerolysis, deacidification, and in most of the cases, distillation. What you need is just an enzyme, and if with simplified and simple operation, you can produce biodiesel with feedstock that is easily available to you, near to you, and at an affordable price. So the benefits in this that you can see is that you get a high yield because the byproduct that is created is recycled back into the process, and we see less yield loss, and that's why you get a high yield. It operates at mild temperature, thus saving energy, and it does not require additional steps, thus saving energy for you. In low FFA case, you see the high purity of glycerin that is produced as a byproduct and fetches high value in the market. And at the same time, the setup is just an add-on process. It is not a very big setup that needs to be done. Enzymatic process is just an add-on, and it can be easily retrofitted with some guidance. And with interest of time, I think that will be all from me. Thank you.
We can take one question if any. Okay. Mic there, mic.
Thank you.
Thank you. Thank you. Sorry, in fact, we were supposed to complete the session much earlier, but you know that we started late, so we will not take more time for lunch, before lunch. Oh, you are here. Please come. Please come.
Mine was supposed to be ahead of this.
But you were not here. I was trying to see you. Okay. Okay, you were in the audience. Okay, we will take up, because I have already spoken to them. Okay. Okay, you go ahead, because I was just looking at you, but you were not visible. Anyway. Please continue. Okay, please. Go ahead. Go ahead.
Don't blame them.
Yeah.
All the speakers were invited to be on the dais.
Yes.
That's why we are sitting here.
Okay.
I know Dr. Sambhashi Rao, in fact. Dr. Rao, you know, the holds BTech and PhD Tech in food technology from ICT Mumbai, and he has a vast experience, more than 25 years in the field, and he's director Shirdi Sai Nutraceuticals, because he's a regular, in fact, speaker in our OTI conference. I forgot, in fact, he was not in the dais, so I apologize for that. So I request Dr. Sambarao, please.
Okay. Sorry about that. It's a great pleasure to be here and to share some of the new ideas and thoughts that I have to improve the refining of vegetable oils. Just to tell you, some of these ideas are already delivering far better results in the refining of vegetable oils. My topic is about using the power of enzymes to improve the refining of vegetable oils. When we say power of enzymes, you have heard a lot of times about enzymes in the last couple of hours, but let us understand what enzymes are. Everybody will say enzymes are biocatalysts, they are very specific, etc., etc. That's more like chemistry point of view. In reality, we need to understand what exactly enzymes are. Enzymes are actually tools created by nature to manage the living system's life processes. Any living system, whether it is man or animal or tree or microorganism, in all these living systems, the life is being maintained and sustained by the work of enzymes. So in reality, actually, enzymes are tools of God. So they have phenomenal power. So if we can actually harness the power of these enzymes to do the processing of natural materials, any natural material, whether it could be vegetable oil or any food or anything, you can actually create wonders out of that by using the enzyme power. So in this presentation, I'll try to focus on how we use the power of enzymes to improve the refining of vegetable oils, and what was going on until now in enzymatic degumming, and what are the new improvements that I am bringing to the refining of vegetable oil industry. I'll focus on that. And the focus is more on the degumming of vegetable oils. As you know, the degumming is a step that comes in both the methods of refining. Whether you do physical refining or you do chemical refining, you need to remove gums from the oil. Removal of gums is what we call as degumming step. And degumming becomes very, very critical when we look at the physical refining, because except that specific degumming step, there's no other way where you can get rid of gums in physical refining. That's one. And second, removal of gums completely is an essential criteria to be able to produce high quality, shelf-stable refined oil through physical refining. And therefore, degumming becomes very critical in physical refining step. And I focus more on rice bran oil in this presentation because in fact, India is the largest producer of refined rice bran oil in the world, and almost all the rice bran oil is processed through physical refining. And therefore, I would like to focus on rice bran oil. And just to share with you today, almost about 85% of rice bran oil produced in the country is degummed through enzymatic degumming. So the traditional method used for degumming of rice bran oil was phosphoric acid degumming method. That was actually effective in removing gums to the desired level, but at the same time it was delivering very high loss of about 3% in the degumming step. So this degumming was improved by somewhere around 2001-2002 by bringing enzymatic degumming into the country. And I can tell you that I have the privilege of bringing the enzymes to the rice bran oil refining industry way back in 2001-2002. But this enzyme degumming technology was able to bring down the degumming loss from 3% to a level of about 1.8 to 2%. 2% loss is still very high. So somewhere around 4 years ago, I brought an improved enzymatic degumming solution. Process is the same, but I just selected the right enzyme for degumming of rice bran oil. By bringing that better enzyme, the losses came down from 1.82% to about 1.2 to 1.7%. There's a clear 0.5% improvement in the yield. And now we have just recently launched another new degumming process, what we call as max oil degumming. In the max oil degumming, we are able to bring the degumming loss further down to just around 1%. Even on low FFA rice bran oil, which has about 1, 1.5, even 2% of gums, the degumming loss is just around 1%. So from about 1.8 to 2, we just brought it down to about 1% degumming loss in max oil degumming on low FFA oil. In high FFA oil, it is even less, somewhere around 0.6 to maybe 0.8, 0.9%. So a clear improvement of about 0.8 to 1% compared to the traditional enzymatic degumming process in the yields. So these are some anticipated losses in solvent soy oil. So how do we do this? What is this max oil degumming and what is the basic principle of this? So basically in enzyme degumming, what we do is we try to split the fatty acid from the phospholipid molecule, either from C1 position or from C2 position, and that makes the phospholipid molecule water soluble. So you just remove the one fatty acid from all the phospholipid molecules so that they become water soluble, and you remove that water in the centrifuge, so along with the water, all the phospholipid molecules go out. That's the basic principle of enzymatic degumming, traditional enzymatic degumming rather. So in max oil degumming, what we do is, when you remove one fatty acid from the phospholipid molecule, the resulting molecule is called lysophospholipid. So due to the presence of second fatty acid in the lysophospholipid molecule, the lysophospholipids are still able to carry some oil with them when they go out of the oil. So what we do in max oil degumming is we bring a lysophospholipase along with the phospholipase A1 and put that into the oil, both the enzymes together at the same time. So while phospholipase A1 splits one fatty acid and creates lysophospholipids, and then the lysophospholipase goes there and splits the second fatty acid, converting the lysophospholipids into glycerol phosphate. The glycerol phosphate is a molecule which is 100% hydrophilic. It doesn't have any hydrophobic part in it. As a result, it will not be able to carry any oil with it at all. And therefore, by using a combination of phospholipase A1 and lysophospholipase, we are able to reduce the degumming loss substantially and create an improvement of about 0.8 to 1% extra yield compared to the traditional enzyme degumming that has been in practice the last 20-25 years in India. So that's what we do. And combination of PLA1 and lysophospholipase is what we call as max oil degumming. And it's actually going on right now in about 4 refineries with improved results. People are very happy with the improvement in the yields that they're getting out of max oil degumming. And let's come to the chemical refining. In chemical refining, as we know, we first degum the oil through water degumming. The hydratable phospholipids are taken out through water degumming. Then we have non-hydratable phospholipids and free fatty acids. So we try to remove the free fatty acids by putting alkali to convert them into soap. In the process, the non-hydratable phospholipids also are taken out. However, the critical problem here is, as long as you have the non-hydratable phospholipids in the oil at the time of neutralization, you will not be able to neutralize the free fatty acids using the stoichiometric quantity of caustic, because the phospholipids would interfere with the neutralization of fatty acids. As a result, we end up using large excess sodium hydroxide to neutralize the fatty acids. And when you use excess sodium hydroxide, that excess sodium hydroxide is going to go and attack the triglycerides, resulting in the saponification loss. So you have a good amount of saponification loss happening, and so the losses, neutralization losses are very, very high. That's one problem. And second problem is the phospholipids are going into the soap stock. So when they are there in the soap, you cannot actually convert this sodium salt of fatty acid back to free fatty acid very easily. Phospholipids would again interfere there. So that forces you to use large excess sulfuric acid and then boil it for a long time to be able to recover fatty acids and oil from the soap stock. So in either way, in one way you are losing a lot of neutral oil, the other way you are using huge amount of chemicals and then creating a lot of effluent, all because of presence of non-hydratable phospholipids in the oil at the time of neutralization. To minimize this problem, what the industry has been doing is they were just using phosphoric acid to precipitate the non-hydratable phospholipids so that their interference in the neutralization is minimized. But there is still good loss and there is still problems connected with the recovery of oil from the soap stock. So the best solution for this is, instead of precipitating the non-hydratable phospholipids, if you can actually hydrolyze them using the enzymes and remove them from the oil at the time of neutralization. Oil has no sediments, no phospholipids at all. It just has free fatty acids to be neutralized. If you can create that kind of condition, then you can easily neutralize the fatty acids at 55 degrees centigrade using just stoichiometric quantity of caustic. So when you use the neutralization, when you use only stoichiometric quantity caustic, there's no free caustic available for saponification. And since we do neutralization at 50 degrees centigrade, again, saponification cannot take place at all. So by doing this, we actually prevent saponification loss. So we end up increasing the yield of oil up to about 0.2 to 0.3%. That's one benefit. The other benefit is the soap we are generating in the process, it doesn't have phospholipids because we already removed the phospholipids using the enzyme earlier. So when there are no phospholipids in the soap, you can easily convert the sodium salt of fatty acid back into free fatty acids by using much less sulfuric acid at much lower temperatures of as low as 85 degrees centigrade, and you recover oil from the soap stock. This oil is absolutely free from gums, so it's of high quality. Since you don't boil it, there's no polymerization, there's no oxidation, there's no high color. You actually recover high quality oil from the soap. This high quality oil can be an excellent feedstock either for recovery of free fatty acids in the distillation or for a biodiesel process. The acid oil coming out of today's traditional process is very high in phosphorus. The yields of biodiesel are very, very poor out of it. It's very difficult to handle that subsequently either for fatty acid recovery or for biodiesel. But in this process, the acid oil you get out of soap stock is excellent raw material for biodiesel production or for fatty acids. And there's no pitch. We don't create any pitch at all while we recover oil from the soap stock. So there's no pitch, high quality oil, and the best thing is you reduce the consumption of chemicals you reduce consumption of sodium hydroxide by 40%, you reduce consumption of sulfuric acid by 40%, you reduce consumption of lime by 60%, you reduce generation of calcium sulfate by 60%, there's no pitch, high quality oil recovered from soap, and the best thing, even the better thing is, the neutral oil you get out of this process has not more than 3 to 4 ppm phosphorus, while the neutral oil you get in the traditional process has a phosphorus content of anywhere between 8 to 18 ppm. In fact, most of the times, when the oil is being fed to the deodorizer, the phosphorus content is more than 5 ppm in the traditional neutralization, while here we are delivering less than 5 ppm even before the bleaching process. So you actually end up getting a refined oil with much better self-stability in this process. So it is high yields, substantially reduced consumption of chemicals, no pitch, high quality oil recovered from soap stock, reduced load on the effluent. So overall, much better process and highly profitable process. So this is what the power of enzymes can do. it can actually transform the way the vegetable oil is refined in the chemical refining process across the world. So this is the power of God. So that's all I have to share with you. And if you have any questions, I'll be happy to take. And by the way, we have been, somebody was asking a patent in India. We've been granted a patent for this in India. Enzyme assisted chemical refining. Yeah.
Dr. Rao, thank you very much. Any question? If you have any question, otherwise you can discuss during lunch. But if somebody is having one question, yeah. Nobody? Okay. Dr. Adhikari, yes, please. नीचे जरा ये दे दो। Dr. Rao, please.
I mean, if you use one single enzyme, which is the case in the traditional enzymatic degumming, in that scenario, all the phospholipids will become lysophospholipids, and the lysophospholipids are completely different in their behavior and properties compared to phospholipids. Just to tell you a bit more, the standard phospholipids are, they have a HLB value of around 4, average HLB, and they are good for water in oil kind of emulsions, while the lysophospholipids have a HLB of around 10, and they're actually good for the other kind, where you want to disperse small amount of oil in a huge amount of water, completely opposite kind of emulsions. So they're very fundamentally very, very different.
No, it's okay. Yeah? Please, please.
Thank you. Thanks a lot. Thank you.
In fact, our last speaker in this session is Mr. Sushil Srivastava. He is 1993 BTech from HBTU only, and he is currently the senior general manager at Patanjali Foods Limited at Chennai, I think, Chennai plant. Sushil Srivastava ji. Yes.
All the honorable guests and students and first dignitaries on the dais. The Patanjali group entered in the HBTU oil sector in 2017 with a slogan of physically fit. So physically fit soybean and sunflower oil that time was processed. After that acquisition of the Ruchi soya, it was just entered in the palm oil. So palm oil processing, like then backward integration, what we call, they focused on this plantation. We are having 6 big port-based refineries and pioneer in the palm oil refining, highest seller of the palm oil, olein. If you talk about the palm plantation, any vegetation starts from the small seed. Seed is cultured, then germinated, then after that it is sifted into the plastic bag or containers. When these leaves start to come, then it goes to the nursery. From nursery, it is shifted to this plantation. This plantation is very specific in cubical form, 9 meter cube. Distance is maintained just for the proper growth of the palm plantation plants. So this is our scientific name. What we call is Helicis guineacis, family Ericis, common name for macaw fat. Origin was South Africa, but it is spread all across the world. Now the major producers are Indonesia, Malaysia, and other countries. The palm oil is grown throughout the humid tropics. The basic condition actually required in palm oil is 30 to 32 degrees Celsius temperature, ambient temperature, 250 centimeter range, and humidity up to 70 to 100%. So the best countries are West and Central Africa, Far East and Central South America. And now India has also entered in the palm plantation, particularly we call the Patanjali. We have more than 80,000 hectares now plantation, and very soon we are going to touch 1 lakh hectare. Oil, the palm oil is obtained from the fleshy mesocarp, the fruit and the central kernel. Two types of oil there, one is CPO, we call crude palm oil, and second is the palm kernel oil. The fleshy mesocarp, the fruitlets, contains approximately 50% oil by weight, and kernel between almost 50 to 54% oil. The fatty acid composition of the palm oil makes it a very crucial, very specific, because it has having the combination of the saturated and unsaturated both. If we talk about the saturated, it is basically basically palmitic, almost 44%, and 5% around stearic acid, and 1% myristic. And if we are talking about the unsaturation, it is having 40% oleic and 10% linoleic. So this makes it very specific product after refining for the confectionery, biscuit, bakery, and so many other products. If we see any of the in mall about the biscuits and namkeen, whatever, you will see the palm oil is one of the great ingredients. So there is a big importance because of this is self-life. Once we study about the Ranciba test, it gives the highest self-life among the other available oils. There are types of palm fruits, because everything depends upon the yield, because everybody is worried about what should be the yield of the product. There are 3 types of seeds. First is fruits. First is dura. Dura is classification is based upon the mesocarp. So the dura contains about the 45 to 65% and shell 25 to 35%. Second variety is Spicifera. It is having no cells, and it is not a commercially cultivated also. It is just for the breeding purpose only. Third one is the most important, Tenera. It is a commercial fruits. It cultivates it is having oil content, much oil content. And if we, on an average, we see it gives up to the 3.5 to 4 tons oil per hectare. The super hybrid variety of the Tenera is also developed. It gives 5 to 7 tons. And some other varieties, new varieties also developed, which is giving up to 10 tons oil per hectare. This is an advantage. This is highly efficient producer of all other than oil. Why palm oil is preferred among the other oil? Because it takes, because of high yield. If we talk about the yield, this is the highest yield per hectare, up to 3.5 tons per hectare. If we talk about the other oil like rapeseed, it is 0.8 tons. If sunflower is 0.7 and soybean is 0.5 tons. Top producing in countries are Indonesia, 43 million metric tons, Malaysia 19.71, Thailand 3.6, Colombia 1.88, Nigeria 1.5 million metric ton, Guatemala 8,90,000, Papua 8,20,000, Cote d'Ivoire 6 lakh ton, Honduras 5,95,000, and Brazil 5,85,000. The global palm oil market size was estimated USD 74.4 billion in 2023. The global palm oil market is expected to grow a compound annual growth rate about 5.1% and expected to reach USD 100 billion by 2030. This is attributable to increasing consumption in oleochemicals production of agrochemicals and cleaning products. Key factors that are driving the market growth include increasing demand for palm oil derivatives, oleochemicals, pharmaceutical uses, biofuels, cosmetics from different end-uses industries. Palm production of India, if we talk 3,05,000 ton India produces at present 2023-24 figure, it is almost 0.38% of the global market. Out of which the palm oil import was 9 million ton, which is 56.4. The types of palm oil, we import crude palm oil as well as the palm oil, and countries from where we are importing is Indonesia, Malaysia, and Niger. because why it is required to just control the price of in the India, the import is required. That's why now on the basis we are just working more on the plantation so that Atmanirbhar Bharat may be dream may be successful. Palm oil processing, if we talk, the main steps are fruit bunches, sterilization, stripping, digestion, extraction, and kernel recovery because it is having kernel inside, kernels separation, kernel drying, bagging, and extraction of the kernel. Fruit bunches are cut down after the when plant actually started giving the fruit after 4 years. So after harvesting, these are cut down. The sterilization is the heart of the plant, just like preparatory of the solvent plant. It is the main core, plays very core role in the palm oil mill. Sterilization of palm fruits is done for heat treatment of the absorption of the moisture. It prohibits the growth of the fungus, especially on the damaged fruit. During sterilization, enzyme called lipolytic becomes inactive as well as it also prevent forming the other free fatty acids. Because our target is to produce the low fatty acid palm oil. The time of the sterilization depends upon the size fruits, while the standard time and temperature is 50 to 90 minutes and temperature 135 degree. Normally it is heated in 3 peaks, single, double and triple, depending upon the size. Stripping is done to separate the fruits from the bunches. For a small mill, which we have capacity of 5 tons bunches per hour, beat arm stripper is used with the rotary drum that can handle quantity up to 20 tons per hour. Second step is digestion. Digestion is primary pressing before final extraction, where slowly rotating oil-bearing cells are ruptured by rotating beater and thus produce mass of mesocarbs and nuts. The process of digestion is carried out at 95 degrees Celsius. Extraction of oil from the mass is done with the help of the screw hydraulic or centrifugal presses. This method is known as dry method. Extraction of palm oil can also be done through wet method while mixing the water in that. But in that a lot of effluent is generated, so normally dry method is preferred, in which the water consumption is only 3.5 meter cube. Similarly, when palm kernel oil processing, here only 2 steps are there. One is nut separation, then nut drying and cracking. These are the key processing steps which are adopted. If we have taken just a small example, right from the fresh fruit bunches, 1000 kg suppose taken, then sterilization, steam is given, condensate is generated, then stripping, empty bunches separated to 234 kg, fruits 665 kg, then digestion, again steam is introduced in digester, then pressing, screening, clarification, and then cleaning this and sludge is separated out, and final oil is we get the final oil, crude palm oil 233 kg. Same is with the nut separation, and after that here also we adopt 2 method, wet and dry both, and kernel drying, then kernel is get 67 kg. This is the total material balance of the FFB. This is our equipment which are used. First is sterilization equipment, in which the caged cart is used, and it depends upon the size, which size of the cart is, which size of the plant is, plant is there, machine is there. It depends upon, it may take the 5 tons to 10 tons of the FFB, fresh fruit bunches. Second step is threshing. The fruits received at mill bunches are detached with the help of thresher or stripper. There are 2 types of thresher. One is rotating drum and another is fixed drum, which are used for the stripping palm oil fruits. Then oil extraction. Oil extraction of palm oil is done either by wet method or dry. Dry method includes use of screw presser for extraction of oil from the palm fruits. This is clarifier by gravitational we just clarify, we separate the oil from the all the material, solid materials and water and other impurities. The upper part is, we get the from CPO from the upper part. This is the kernel separation. Separation of the heavier cells from the kernels is accomplished either by clay baths or hydrocyclones units. The cell can be used for the boiler fuel and road surfacing also. Drying and bagging, and after that oil extraction kernel. This is the schematic diagram: palm kernel cracker and separator, then crusher, then roaster, after the palm kernel oil expeller, then plate and frame filter, just filter out the solids, material impurities, then crude palm oil, palm kernel oil. This is the diagram: crude palm oil and crude palm kernel oil. Now comes the palm oil refining. Crude palm oil generally is very easy because it's having very less phosphatides, less than 25 P contents are there. So only gum conditioning is required. After that, only directly it goes to the bleaching, then deodorization at high temperature to separate out the free fatty acid. Then refined, bleached, deodorized RBD palm oil is received. After that, it is fractionated into the olein and styrene. Olein is directly sold in market in oil packing, and styrene is multiple commercial uses. This is already I had told, bleaching and deodorization. This is simple diagram I had just made, bleaching, how this bleaching is done through plate and frame filtration. It is better to use the slurry form bleaching earth. Okay. Deodorization I am not telling, just because of the shortage of the time. Now the fractionation, which is very important because it gives the commercial realization of the oil. Here our target is to achieve the maximum yield of the olein. So up to 80 to 85% normally olein is received from the palm oil, refined palm oil. This is the characteristics of the palm. It is easily visible. Saturated, unsaturated PUFA and PUFA 37.5 and 49.9. Recent developments or challenges, we can say this one is RSPO certification, second is the MCPD and GE value, and third is that he developed red palm olein oil. RSPO, round table of the sustainable palm oil, which is very important. Why it was required? Because in 1920, this palm oil commercial production was started. So a lot of, because of this high yield and high commercial value, a lot of forests were cut and converted into the palm plantation. So just to reduce this, just to control this round table of the palm oil organization was formed in 2004. Its objective is basically no clearing of ecologically valuable forest areas of the cultivation of oil palm takes place. Observation of legal regulations such as land use and property rights, prevention of child labor, integration and promotion of small farmers, that the plantation are inspected by independent and authorized inspectors. The aim is to support the use of sustainable palm oil through close cooperation between stakeholders throughout the supply chain. This is why the sustainable palm oil, because more than 1 million workers are involved in this, more than 3 million smallholders, many more household members, social issues in the oil palm cultivation, land ownership conflicts, workers' rights and conditions, treatment of the smallholders. These are the few points: grievances and supervise just compliance. These are same. Next is sustainable principles, transparency, use best practices, care for environment, natural resources and biodiversity, consider rights of workers, smallholders, develop new planting responsibly. May mention RSPO certification on your end product, because once you have mentioned, it gives automatically a good value to your product, and the rates also you can get very better realization of the same. Second is MCPD, 3-monochloropropanediol, and second is glycidyl ester, GE. It is supposed that they are carcinogenic in nature. So how to just remove these from our palm oil? This is just, it is seen that 15 to 17 chloride ppm is there in the RPO. It comes from it is not natural, it comes from during the processing. So how it can be reduced? Generally it is, if we wash out the palm oil, about 85% chloride gets free. I will show you how it is generated. This is the total cycle from water that we use, treatment, then boiler, from boiler to turbine, turbine to back pressure steam, and different operation where open steam is used, sterilizer, crude oil tank, dilution tank, clarifier, etc. These are the ppms that it gets from the 8 ppm from steam injection, 22 from the treated water, top pressure filter, steam injection, etc. So reduce chlorine in fresh palm fruit bunches by changing fertilizer use, reduce DAG in palm oil by ensuring milling within 48 hours, improve quality of fruit palm oil, wash fresh palm fruit bunches to remove chlorine precursors, fresh palm fruit bunches sterilization with steam without chlorine, wash fresh crude palm oil with slightly alkaline water, wash the crude palm oil as a refinery and minimize residence time and temperature during dehydratation to extent possible. Elimination of chloride in palm oil, I already told that 85% of the chlorine can be removed through washing only. The simple process is just after washing directly we can bleach it with the neutral bleaching earth, then we can directly deodorize at 250 degrees Celsius. And again next process is, again we can go for the bleaching of the same with activated bleaching earth, but deodorization at low temperature, less than 200 degrees Celsius. Here are the certain steps to reduce the MCPD, minimize formation in the deodorization limit temperature and residence time, re-refining with activated bleaching earth followed by mild deodorization and direct stripping. Not sufficient to reach levels well below 0.5 to 1 ppm for palm oil or similar, especially for low color product requirements. Can reach 0.2 to 0.3 ppm, but post-refining has been operating cost and does not completely eliminate GEs. Direct GE stripping can reach levels below 0.5 ppm subject to GE content in the feed. Quality of RBD palm oil, this is 0.5. If we use the GE tower, it is 0.023 to 0.04. Moisture and volatile matter 0.05, with GE 0.03. Color is okay, 2.5 normal, and in rear 2, PV 0. And most important 3 MCPD, that 4 to 6 ppm normally remains in the normal deodorization, but it is in G it is less than 1 in single, and G 8 to 15, and in G tower 0.3 to 0.5. To avoid the re-refining, it is better to go with the G tower. Third, red palmolene. Red palmolene, actually these beta carotenes are present in the palm oil, so it was supposed, why not just to retain this red carotenes in the palm oil, because it prevents the atherosclerosis, the narrowing of the blood vessel. So it was thought to just retain the properties as it is in the oil. Second, this vitamin E reduces the problem of the dementia in the persons, because the free radicals are responsible for all these, and it reduces the free radicals in the body. This is simply very simple process, just degumming. Degumming is only conditioning only we require. Then caustic neutralization is required in this process to retain the color. Second is We have to do the deodorization very low temperature, 160, 165 degrees Celsius. Then after fractionation, we get the RBD red palmolene and RBD palm stearine. This is all about my this presentation. Thank you. Any question?
Thank you, Sushil ji. If you have one question, only one question. Okay, Sanjay ji, bataiye. Yes. If you can spare mic, नीचे mic दे दीजिए कोई.
Hello, check.
Open steam that we are using should be less than 8 ppm chlorides. The most important is that when we are doing the washing, the very first stage, at that time we should use the RO or DM water, chloride free. That it helps. We have made already, and it is we have testing also. It was found 0.2 only in final product. We have already done the exercise on this. Thank you.
Thank you. Thank you, Sushil ji. Please. I invite other persons who have been a speaker in this session from no sense. Anybody? Okay. Oh, yeah, please come.
Thank you so much, sir. As a token of our appreciation and gratitude, we would now like to felicitate with a memento. I request Professor R.K. Trivedi, sir, to kindly present the memento to Dr. Mark Kellen, sir. Next, I request G.A. Usmani, sir, to kindly present the memento to Mr. Prabhat Kumar, sir. Next, I request Professor R.K. Trivedi, sir, to kindly present the memento to Dr. S.K. Raza, sir. Next, I request Professor G. Usmani, sir, to kindly present the memento to Mr. Sushil Srivastav, sir. Next, I request Professor R.K. Trivedi, sir, to kindly present the memento to Dr. Sambishwarao Javedi, sir. Next, I request Professor G. Usmani, sir, to kindly present the memento to Mr. Radhe Kosik, sir. Thank you, sir.
we would like to also request the chairman of FolioCon, Dr. Praveen Yadav sir, to please join us on the stage for the photograph. I request Chairman of FolioCon, Dr. Praveen Yadav sir, to kindly present the memento of to our co-chairperson, Professor G.A. Usmani sir. I request the chairman of FolioCon, Dr. Praveen Yadav sir, to kindly present the memento to our chairperson, Professor R.K. Trivedi sir. Thank you everyone. You can now proceed for lunch.
आज we had our breakfast like the lunch. We are going to have our lunch like a dinner, but let me assure you, we are not going to have a dinner like a breakfast. It will be a grand. There's an old saying that you must take the breakfast like a king, the lunch like a prince, and the dinner like a beggar. In fact, we are following that thing in some way or other. Please proceed for lunch. Thank you. Thanks a lot for your benign presence.